In this example, we have polar equations and we want to convert them to rectangular equations. So we're going to use algebraic techniques. In example A, we have r equals 1. So one technique we can use is to square both sides of the equation. When we do that, we'll have r squared equals 1. And then we know that r squared is equal to x squared plus y squared. So our rectangular equation is x squared plus y squared equals 1. Now, what is useful about changing a polar equation into a rectangular equation is this is an equation that you learned how to graph back in geometry, or at least in Algebra 2. This is a unit circle. The center of the circle is 0, 0. The radius of the circle is 1. So if we wanted to graph the circle, we would go out 1 from the center, and that's what the graph of that equation would look like. In example B, we have theta equals pi over 4. What we use this time is we're going to take the tangent of both sides. So the tangent of theta equals the tangent of pi over 4. And then we can use our definition of tangent. Tangent is defined to be opposite over adjacent, or y over x, on our unit circle. And the tangent of pi over 4, that's one of our special right triangles, is equal to 1. So we'll end up with the equation in rectangular form, y equals x. And that is just our main diagonal. The last example, we have r equals the secant of theta. And so for this one, let's first of all remember that secant is 1 divided by cosine. And so if we multiply by cosine on both sides, we'll have r times the cosine of theta is equal to 1. And then r times the cosine of theta is defined to be x. So x equals 1. So if we graph this equation, we're going to have a vertical line at 1.